As the last part of this lecture on the Rankine cycle with open feed water heating, or the concept of regeneration, we can do a parametric study using fluid prop with Excel. So on the course website, I have a sample Excel spreadsheet using fluid prop to analyze the model that we just created. And let's see, I've got the pressures set in terms of the highest pressure and then the lowest condenser pressure. I've got the isentropic efficiencies of the turbine and the pump listed. And then I work my way through the cycle just for each column using two properties, two things to fix each state. You can download the spreadsheet and see exactly, compare that to the example that I've worked on. I've got the superheat defined as a constant 480 Celsius. What I'm doing is I'm varying the intermediate pressure, at which I'm taking fluid out of the turbine and putting it through my regenerative feed water heater. So I'm varying that pressure, and then I'm progressing through the cycle, calculating the properties at each state. And then finally I can calculate my specific heat transfer. I can calculate the percent of fluid that was bled off from the first turbine stage. I can calculate the total work of my turbine, what it took to drive my pumps, and then finally the thermal efficiency of the entire cycle. Let's look at the graph below showing, let's see, the dashed line is the efficiency of the cycle. And we can see a optimum point. If I go back to the data, that looks like, let's see here, 38.3%. It's looking like the optimum efficiency here. That gives me the most bang for my buck. Let's look at this in more detail, however. I'll try to outline that. That looks to be about 5 bar for my intermediate pressure. I go through my first turbine. Now that looks good. I have an exit quality of 99%. I go through my regenerative feed water heater. I go through my second turbine, and I see a exit quality of 84% at the exit of my second turbine. And again, that's much too low. I need it to be 90% or greater. I look at the data here. I don't see getting to that. So a few options. Well, I say a few. The first thing that comes to mind is one option would be to raise the superheat temperature. That should move everything further to the right and result in increased quality at the exit of the second turbine. Another option could actually be use reheat. So this would look like combining the concepts of an open feed water heater and reheat as well to make sure that second turbine then has increased performance in terms of the exit quality. Okay, thank you for your time and for exploring this with me.